Hi Year 11, Mr. Wilson here. Today, another electromagnetism practical. This time I'm going to induce a current in a wire by moving a magnet through a solenoid. To measure this current, I'll introduce you to this. This is the galvanometer. This is measuring extremely small currents. You can see the light on the scale on the galvanometer. If there's a current passing through it, we will see the light move that way for a positive current and that way for a negative current. So it can show currents moving in both directions. Here I've got my solenoid, this coil of wire the wire is connected into the galvanometer. It's hollow through the middle, so I can move a magnet through the coil. As I move the magnet through the coil, we will see a current induced in both directions, depending which way I move the magnet. So here we go, here's my magnet. I'm going to come down through the coil, and you should see that as the magnet moves, the scale is showing that I'm generating a current. And depending which direction the magnet's moving, sometimes it moves, sometimes you get a positive current, sometimes you get a negative current. It's actually more complicated than that as well though. So here I've got my positive end of the magnet. So at this point, the magnetic field lines are poking out of the magnet. At this end of the magnet, all the magnetic field lines are pointing out, coming out like this. So they're pointing one way. When I move that through the coil, just there, we see it goes positive on the way down and negative on the way up. This end of the magnet is the south pole, and at the south pole, we've got field lines moving into the magnet. So they're going the opposite direction. So I've reversed the direction of the field relative to the coil. This time, as I move it down, I see negative, and as I move up, I see positive. Down is negative, up is positive. Down is negative, up is positive. And we can actually see that as the magnet moves. So if I lift the coil up a little bit, we can see the effect of both, so I can move the magnet all the way through. We can see the effects of the two separate poles moving through the magnet. So here we go, watch the current. It's going to go positive, negative. Because first the north pole moved through, then the south pole moved through. Positive, negative. Positive, negative. Positive, negative. There we go. So we've seen magnetic field moving relative to the electrons, which induces a current in the electrons.